Hey, welcome everybody. This is Bailey representing the EMH, the Elephant Money Herd. And you're here for Never Forget Math Lessons number 6, Price and Parabola. That's going to bring us to our quote of the day. Big shout out to Stunna Breezy. All right, I was watching his video today and he said the parabola is coming. The parabola is coming. So hey, I just want to thank Stunna for all the excellent videos and entertainment that he's providing, and a lot of coverage of elephant money. So I paid his little Flex Zone Telegram group a nice little visit a couple of weeks ago and let them know about all the the good things that they can expect from elephant money to come, a little parabola. And ever since then, he's been pretty much covering it every day, on his channel. So, I appreciate that. And yeah, but it doesn't seem like he's too convinced, but that the parabola is really here. I sensed, through some of his, really expert analysis of the charts and everything, he is not a believer of it. And but he's made some good arguments, and I started to actually question it myself. I'm like, is this really, the case? I don't know. So I was like, well, what does a parabola really look like? So let's kind of see if this math actually adds up or not. I don't know. All right. So guys, look at this. All right. So here's like an equation. So a parabola you can think of as y equals x squared. That's the most basic parabola you can get. It's called a parent function. All right. So all the other ones are going to kind of look similar in nature to this shape right here, guys. All right. And so here's our red kind of parabola right there. And you can actually kind of put a number in front of this x squared. All right. Us fancy folks call that a coefficient. All right. And that can have an impact on what your parabola might look like. All right. If you notice here, I have a blue parabola with a big 3 in front of that. And that's actually going to multiply all of our values by 3. And notice how that parabola actually stretches up, or it shoots up even more rapidly. It kind of increases the rate of change of that parabola, makes it shoot up quicker. All right. And then, guys, we can have in front of there perhaps a fraction or decimal that is less than 1. All right. And if you notice what happens here with my green parabola, it actually decreases its rate of change. It actually gets wider. All right. It's a little slower to kind of get up the hill there. All right. And say, hey, 1/10. Okay. A fraction that's even smaller in value. All right. So the parabola's even wider. All right. Stretched out even more. And hey, 1/100. Look at this. Okay. So, guys, that parabola is going to take a little bit of time, but eventually, like always, it's going to start skyrocketing in value, okay, and in nature. So I was like, all right, what's going on? It looks like, okay, I got a parabola here. I could probably identify this from sight, okay? So, all right, I got an idea what it looks like. All right. So, hey, Mr. Breezy, he's been like going through all of the charts and analysis on elephant money, and he's looking at it at all angles. Sometimes he zooms in, sometimes he doesn't zoom in. And I'm kind of with him. I don't know, like this. I'm looking at it, I'm not sure, is this actually a parabola? Okay, let's see. Like we had the exploit, and we know that that was, right there, that was the parabola, and that's what everybody's like talking about. And then we had a crash down, and then since then, guys, it's moved up like a millimeter, right, on this chart right here. So it's kind of steady, just kind of crawling along. Like, is this going to be a parabola? I don't know. So I zoomed in. All right, so we zoomed in, and I went to like the 3-month chart, and hey, nice looking chart. All right, so this has increased. All right, it's almost at like 100% gain from here to here. Okay, that's not bad at all. All right, but I don't know. doesn't look like a parabola. Okay, it looks like a nice steady incline. And then I just went to the 5 days, and it's like, yeah, it's all right, going down, coming up, going down, staying steady. Like, is this thing really a parabola? All right. I don't know. Uh, I'm starting to question this. I really am. All right. Let's see. All right. Hey, welcome to math class, guys. We got to figure this out. We have a mystery to uncover here. And we're going to see if elephant money is what it's all cracked up to be. Like, is this going to be an explosion of parabolic proportions? All right. Is this supply squeeze? Is Bertha just sucking up and collecting all of these tokens from the liquidity pools? Is this thing actually legit? Like, what is going to happen here? All right, so guys, if you've remembered my previous math lessons, okay, we've been talking about two really big things. The constant product formula right here, all right, and this kind of governs how all of the prices in a liquidity pool are related to one another. All right, all the quantities, as one token goes up, the other token goes down, and it all relates to this constant product formula. All right, those are all called ordered pairs or little combinations that will be on that graph and on this equation. All right, and we also, guys, I've been figuring out a lot of like, hey, when are we going to hit the 10x? When are we going to hit the 100x? And in order to do that, you have to actually know how to calculate, say, the price of an actual token. All right. So, hey, you go to the ticker symbols and you look up elephant money, and then like it will spit out a price of what it's going for. How does this price get determined? All right. The calculation behind it. All right, was this formula right here that we've been using. And it's your B&B that's in your liquidity pool times the price of that B&B. All right, that tells you the total value of B&B in your liquidity pool. All right, which is going to be, looks like we got 46,000 B&B right now in our liquidity pool. And the value of your elephant is going to be worth the same amount as the value of the B&B in there. Okay, the elephant that's actually in the liquidity pool. Okay, and in order to get the price, you can actually just do the total value of your B&B divided by the number of elephant tokens. All right, we got about 106 trillion sitting in there right now. All right, and that's going to give you the price per elephant token. And it's going to be this crazy number right here in scientific notation. Okay, that's a small number. Zip it on over 7 times. We got our 6 zeros. And what we want to do, guys, is a lot of times when we talk about elephant, we want to multiply by 1 million so you can make that number a little bit more easy to read and comprehend. And instead of price per elephant, we're looking at price per million elephants, okay? And that's going to bring us, guys, so 10 to the 6th power, that is 1 million. And that's going to bring us to about 11.5 cents per million elephant tokens right now, as we stand with kind of the current price of B&B. And yeah, it hasn't been that great. It's 266, 34 at the time of this recording. All right, so guys, that's where you're going to get this symbol, and that's where you're going to see all of the price right here. Okay, so that's where that price number comes from. Okay, all right. Okay, so guys, we got our liquidity pool. All right, our constant product formula. All right, I can find that constant. I just multiply the B&B that's in the pool right now by the 106.5 trillion tokens per elephant that are in that pool right now. And I get this humongous constant right here. All right, and that's going to be what's called my constant in the constant product formula. All right, so these two equations here, we've been working with quite a bit to kind of see where we're at in our liquidity pools and why we're so high on the system and the protocol. All right, but hey, guys, we're going to create something new today, and that's going to be our price equation, all right, for elephant. So this is the equation that we can use to find the price of our elephant token, and we're going to be able to graph that and show the relationship between the B&B that's in our liquidity pool and what the price of the elephant token is actually going to be. All right. So here's how we do it, guys. It's basically we're going to be kind of squashing these two equations together. All right. And kind of rewriting it to see if this thing is actually a parabola or, is Stunner right? Like in his analysis, it's just, kind of going up and down each day, doing nothing, losing money, like, and then gaining a little bit. But like, where's this big value coming from? Right. I don't know. Let's see. Let's see if it happens. All right. So, guys, so our two equations, here they are. All right. So we got our x times y equals k. All right. That's our constant product formula. We got our number of BNB tokens times the number of elephant tokens. So we're going to be working with that formula there. And then we got this bad boy right here, which is going to be our price per elephant. All right. That's how we've been calculating it. And we have our BNB times that price or value of the BNB. That tells us how much money is in there from the BNB side of things. Divide that by the elephant tokens, okay, to get price per elephant. All right, and then times 10 to the 6th power. So that's gonna be price per million elephants. All right, so price per million elephant. Hey man, Bailey, what are you doing? All right, price per, let's do the little million right here. Million elephants, price per million elephants. There we go. Yeah, price per million elephants. There we go. I just like writing millions, because these are like all the multiple millions that all of our elephant holders are going to have someday. All right, let's see. I hope. All right, so here we go, guys. Ready? So we have this equation right here. All right, so here's what we're going to do. Okay, what I'm going to try to do is kind of get the elephant tokens to disappear from our equation. All right, because I want to have an equation now that's going to have just two unknowns. All right, and those two unknowns I want to have are the BNB and then the price. All right, right now with this equation, all right, I'm a little GM'd up because it kind of has like three variables or like three unknowns. Like it's got this thing here, the BNB, it's got the number of elephant tokens, and then it's also got this price that you're trying to figure out. So there's like three things that are like missing. And like in order to kind of graph that and graph it effectively, you want to have just two things unknown or two things missing. So I want the BNB and then I want the price. So I want to get this thing out of here. Okay. So I don't want this, the number of elephant tokens. Okay. So what I did, guys, was I took our constant product formula and I solved it for y, which means you get y alone. So I want to divide this by x to get it out of there. And you'd have to divide the other side of your equation by x as well, all right, to keep your equation equal and balanced. And we have y equals k, which was that huge constant I didn't want to write out. I just kept it k to make it easy, divided by x. Okay, so that's how you would kind of rearrange that constant product formula to get one of those variables alone on one side of the equal sign. And then, guys, when I'm going to come in over here, I'm going to take this equation and then this y right here, I can replace that with its equal. All right, in math, we call that substitution, replacing something with its equal. All right, so instead of having a y here, I'm going to pop this k divided by x there, because that is the same exact thing as y. It has the same value. So I rewrote this equation, and instead of y, k divided by x. Okay. But what that effectively did for me, guys, is now there's only two unknowns there. All right, there's no y in that equation anymore. There's just x's and then that unknown price. Two unknowns. Good. All right. Now, guys, we're going to clean this up a little bit, okay? Because this looks a little nasty, guys. We're dividing, and then we're dividing by a fraction. That's like enough to make your head spin, right? So basically, this large fraction bar right here, all right, means divide. And when you divide by a number, you can also multiply instead. And you can multiply by what's called the reciprocal. You can flip it over. All right. What does that mean? All right. Instead of dividing by 2, you could also multiply by 1/2. All right. Instead of dividing by 3, you can multiply by 1/3. All right. And it gets even crazier. All right. Say if you wanted to like divide by a half. If you want to divide by a half, how many 1/2s go into something? You actually multiply by 2. All right. If you wanted to divide by like 1/4, like how many 1/4s or how many quarters go into something, you multiply and then you flip that 1/4, multiply by 4. Okay. Because there's 4 quarters in every whole. So then you multiply to get that. So you can actually just do a little flipperoonie and we multiply by what's called the reciprocal, which is x over k. Okay. And what I did here, guys, was I just kind of rearranged these two things right here. All right. Because everything's multiplied together. So you can change the order. All right. It's the commutative property of multiplication. Dropping that knowledge on you guys. You can't beat it. This is free education right here. All right, and we're learning something here because oh my gosh, wait a minute. All right, price of B and B, okay, times the million for the million tokens. All right, times that X times this X, and then we're gonna divide by K. All right, if I simplify that, guys, I'm gonna have this big old number here divided by k, but x times x. Wait a minute, x times x, x squared. All right, x to the second power. I think I've seen that before. Wait a minute, I've seen that before somewhere. Yes. Oh, it's a parabola. Oh my gosh. Wait a minute, this is a parabola, guys. The parabola, is it coming? Wait a minute. All right, let's see here. Okay, let's clean this up a little bit. Okay, I'm excited. All right, so here it is, guys. So what I'm going to do now, all right, so I'm taking this equation and I'm now going to kind of redefine the unknowns, redefine the variables. There's 2 of them. I'm still going to stick with X being the number of B and B tokens. All right, but now my other variable, my Y, all right, so it's that price. I'm going to now call Y price per million elephants. Okay. And here's how you get it, guys. So all we're going to do is to figure out the price per million elephant. All right. Is price of the B and B, all right, times a million, and then divide by that K. Now I put that crazy number from K in the constant product formula, okay, into the equation times X squared. All right. There's my K right there, guys. Okay. All right. And then, guys, if you want to clean it up, you can. You can simplify this and take away 6 of those if you wanted to. And, guys, that looks exactly like one of those parabolas at the very beginning. Okay. Now, the trick is, guys, that price of B and B, okay, relatively small. This constant and the constant product formula, huge number. Okay. So this is actually like a really, really tiny fraction or decimal. Okay. And the bigger this is, okay, like the smaller the value is. So that's where, guys, when you have like really, really deep liquidity pools, right, like Elephant has, you know, that constant product and that constant product formula is going to be big. Okay, which makes that fraction like a small fraction in front of your x squared. So that parabola is actually going to be pretty wide. All right, so that's kind of like this guy right here. So that's where it's like, hey man, you got deep liquidity. All right, that, you know, it's going to be a trek, but it's going to be well worth the travel. Okay, but yeah, you don't go up as quickly when you have really deep value in your liquidity pools. Okay, so there it is, though, guys. That is our parabola, and that's going to model actually our price action if, you know, we have B and B staying steady at this rate. Okay, if B&B goes up, our parabola will get steeper. Okay, if B&B goes down, the parabola gets less steep. Okay, but overall, guys, we're going to be following this price trend in the very, very near future. Okay, this is where we're at right now, guys. We got about 46,000 B&B. And notice on the ticker symbol there, next to the ticker symbol, it was 11.5 cents per million tokens. So that's where we're at right now. And as we keep getting a little more B&B in there, okay, we're going to start to see a rapid acceleration in the value of elephant token. All right. So, guys, want to thank you for tuning in today. There's tons more to follow with this formula. So we're going to be like diving deep into it and everything like that. But I wanted to try to keep this video a little bit on the shorter side. So thanks everyone for your support. All right, thanks for tuning in. All right, love you guys. Also, thank you, Stunna, for all you're doing for the elephant community, highlighting it every day in your videos. You know, we really appreciate that. And yeah, I'm just playing with you. No, I love your videos, man. You're awesome. All right, so thanks everybody. Really appreciate it. All right, till next time. This is Bailey from the EMH. I'm out.